The last pattern we are going to look into is iterator pattern. The last pattern in behavioral pattern. So what is iterator pattern? It provides a way to access the elements of aggregate object sequentially without exposing its underlying representation. So if you happen to have a case where you have some internal aggregate of some object, and you do want to hide that internal aggregate structure, instead you want the client to be able to use to access the object in sequential order. That's when you want to use iterator pattern. And Java already provide iterator, right? So we're going to just simulate it. So Java iterator is in fact using the iterator pattern. So we have iterator interface. It represents abstraction defining iterator. I should actually rewrite this statement. Then we have a concrete iterator, which basically implement the iterator. Basically, is next, get next, and things like that. And the container interface, it represents aggregation. And then concrete container, this is the one that actually provides internal aggregation. Okay. All right, so let's take a look at the iterator example. So we have two containers. So one is animal container, and this one is actually maintaining animals in a form of array. So this is internal aggregate representation is using array. And then we have a flower container. Flower container is using list of string as internal representation. Now what you want to do is you want to hide this internal representation from the user. So user will just use iterator interface. So iterator interface is basically has next method and the next method. Okay. And then we have actual I container. I container will actually create the actual iterator object, and then we have the animal container contains this. In this case, we actually have the inner class called the animal iterator, which implements this iterator. And basically this animal iterator will provide the implementation of has, next, and next. Okay. We actually make this one as the internal class because this is used only in the context of this internal representation. Okay. I mean, you can certainly take this out if you want to, but because it access in fact, you know what, this is actually internal class because it has to access the private attribute of the parent class. Okay, so in this case it has to be internal class, the inline class like this. And the flower container again provides the flower iterator object, the class implementing iterator, and basically it does implement has, next, and next, the method implementation. Okay, so as far as the client is concerned, this good part. Client does not need to know, client does not need to know the internal data structure of the containers. It doesn't know how animals are in fact represented inside the animal container. It doesn't have to know how flower is actually represented internally, right? It just uses the iterator. Okay, so basically if I run this code, okay, so it's just accessing animals and flowers. So this code does not need to be changed regardless of the internal aggregate representation of animal container and flower container. Okay, so it actually provides some kind of abstract way of accessing elements in that aggregate. Again, you know, the JDK has iterator interface, right? So you're basically simulating that with the iterator in our example. Okay. All right. So let's see whether we have a homework for that. Yeah, I'm not sure we have homework for that. Okay, that's fine. Yeah, this is pretty straightforward.